Now that we've talked about physical properties of matter, we're going to look at how matter gets classified. So one of the first ways that matter is classified is that it can be a mixture, and there are two types of mixtures. We have homogeneous mixtures and heterogeneous mixtures. And a mixture is a physical blend of two or more components, each of which retains its own identity and properties. So an example of a mixture would be salt water. It still remains salt and water. They don't combine to form a new substance. I think a more obvious example of a mixture might be like Chex Mix. It has the Chex pieces, it has the garlic chips, it has the breadsticks, it has the pretzels. And so when they all get mixed together in a bag, a pretzel's still a pretzel, even when it's part of Chex Mix. So a homogeneous mixture then is a mixture in which the composition is uniform or the same throughout. An example here would be air. Pretty much every breath you take in has maybe it's like 78%. Ooh, it's probably not that high. 70-some percent, we'll just say approximately 70% nitrogen, approximately 20% oxygen. And so every time you breathe that in, you're getting about the same ratio of nitrogen and oxygen. Salt water is another example of a homogeneous mixture. A heterogeneous mixture is a mixture in which the composition is not uniform throughout. So example here would be chicken noodle soup. You've got the noodles, you've got the chicken, you've got the broth, and each scoop you take could have different ratios of noodles to chicken to broth. Same another with the Chex Mix. This is a heterogeneous mixture. Each time you take a handful out, you could have different amounts of pretzels to Chex pieces and so on. So a phase is any part of a sample that has a uniform composition and properties. In a homogeneous mixture, there is one phase. In heterogeneous mixtures, there's two or more phases. So if we look at this image over here, we have oil mixed with water. And so there would be the oil phase up top and then the water phase on the bottom. So there would be two phases. Since there's two or more phases, it would make this mixture heterogeneous. So in order to separate mixtures, you can either filter the mixture. This is a technique that separates solids from liquids in a heterogeneous mixture. So if you wanted to separate like sand from water, you could use filtration. Distillation is a method of separating a mixture based on different boiling points. So distillation can only be used with mixtures of the liquid state. And so this is a basic diagram of how distillation works. You need some sort of heat source that is going to heat your mixture. Notice that it's corked at the top here because you want to force the vapors down this tube. This tube will cool the vapor back into the liquid form. So you'll notice that it drops, the drip drops down here. And you will have separated out one liquid from the other. A second type of substance is a pure substance, and an example of a pure substance is an element. This is the simplest form of matter that has a unique set of properties. And so we have, I believe, we have helium here, we have iron, cast iron pan, and then gold. All of these are only made up of one substance. Pure substances can combine to form compounds. This is when you have a pure substance that contains two or more elements that have been chemically combined. This means that there's been some sort of reaction done. So an example of a compound is water. Water will always be two hydrogen atoms with one oxygen atom. Your table salt is always one sodium atom with one chlorine atom. And in order to separate compounds, you have to use chemical changes. Oftentimes, a chemical change will occur when you heat the substance. So for example, if you place sugar in a fry pan, let's say, don't actually do it, your mom will be mad that you wrecked her fry pan, but you heat some sugar up and you'll end up getting carbon and water. So, however, it is important to note that water cannot be broken down into the hydrogen and the oxygen with heat. It requires an electrical current to do that. So a chemical change is a change that produces matter with a different composition. Here is a nice little flow chart showing you how matter gets divided out. It can either be a pure substance or a mixture. Your pure substances then can be divided into either elements or compounds, and your mixtures can be divided into either homogeneous or heterogeneous mixtures. Lastly, when we deal with pure elements, oftentimes we're working with their chemical symbol, and this is a unique 1 or 2 letter designation of an element. This table shows you some chemical symbols and their elements that don't necessarily seem to logically match up. So like sodium symbol is Na, but when you look at the Latin name for sodium, you will see where the Na comes from and it starts to make sense. When we write a chemical formula, we use chemical symbols. It's a shorthand, helps speed things up, I guess, a little bit. And so a chemical formula is an expression that shows the elements in a compound and the relative proportion of those elements.